In this video, we're going to be looking at solving linear simultaneous equations. When solving simultaneous equations, the idea is that you have to work out the value of two or more unknowns that satisfy both equations. Now, for what we're going to be looking at, we're only going to be looking at two equations. Now, the method we're going to use involves making one term in each equation to be exactly the same. And the crucial part here is to make them exactly the same. That will include the sign that goes with them. So for example, here I've got two equations, 5x plus 3y equals 17 and 2x plus 3y equals 8. Both those equations have got a term of plus 3y in them. That's fine. We could now proceed and solve these equations if we wanted to, because the two equations have got exactly the same term in them. The second example, minus 3x plus 5y and minus 3x minus 7y, and equals, well, the top one equals 16, the second one equals 4. That's not important. And again, you can see that both the equations have got an identical term in them. Both got negative 3x in them. So again, with our method, we can now proceed and solve them. Sometimes you're going to get equations when it's not quite as easy as that. So if you look at these two, 4x minus 2y equals 14, 6x plus 2y equals 19. Now it looks like you've got the same thing, but if you look carefully, the top one is negative 2y and the bottom one is positive 2y. So they're not identical, and we have to have them to be exactly the same. Now remember, the sign always comes before the term. If there is no sign, then the term will be positive. So the first step is to make one of the terms in each equation to be the same. So if you look at the example here, 5x plus 3y equals 7, 3x minus 3y equals 10. It looks like we've got some terms which are nearly the same, the 3y and the negative 3y. So the trick here would be to turn the bottom one from a negative 3y into a positive 3y. So I'm going to leave the top one, the top equation unchanged, 5x plus 3y equals 7. That's no difference there. But for the second equation, if you multiply each term by negative 1, or just change the sign of everything, you end up with negative 3x plus 3y equals negative 10. So each term has had its sign changed. If it was negative, it becomes positive. If it was positive, it becomes negative. Now if you look, we've got a plus 3y in each equation, and we will be able to proceed with our method. So example 2, 3x plus 4y equals 17 and 2x plus 2y equals 5. Nothing's the same at the moment, so we've got to do a bit of work. Now, looking at it, the obvious thing for me to go with is the y's, because I can see I can very easily make 4 y's from both equations. The top one's already got a 4y in it. By doubling the second equation, you end up with 4x plus 4y equals 10. Now notice what I've done is I've doubled every one of the terms. So 2 times 2x is 4x, 2 times 2y is 4y, and 2 times 5 is 10. So now I've got 4 y's in both equations, and I would be able to use my method to solve it. Alternatively, maybe it was the x's I wanted to deal with. So exactly the same question, but this time what I'm going to do is I'm going to multiply the top equation, the first equation, by 2, so I'm double every term. 6x plus 8y equals 34, and the second equation by 3. And now if you look, I've got a 6x in both of them. We've got one term to be the same in both equations, so we will be able to proceed with our method. So what next? What's our method going to be? Well, let's do this by an example. 3x plus 4y equals 1. 5x take away 3y is equal to negative 8. So the first thing we're going to do is we're going to make sure we have the same number of one term in each equation. So either the x's or the y's, it doesn't matter which one we choose. We can do that totally for ourselves, whichever one we want to pick. In this instance, I'm going to select the x values. So I'm going to multiply the top equation by 5. So multiplying each term by 5. And I'm going to multiply the second equation by 3. So again, notice every single term has been multiplied by 3. Now this is the important bit. We've got the same number of x in each one. So we're going to have to identify the difference between these two equations. Now the easiest way to think about this one is to take one side of the equation of the equal sign at a time. So let's take the left-hand side. And I'd always start at the lowest, the smallest number of, in this case, y's. So to go from negative 9y to 20y, what's the change going to be? Well, it's going to increase by 29y. And going in the same order, if I'm going to go from negative 24 to 5, that has been an increase of 29. So what we now have is 29y is equal to 29, so y must equal 1. So that is one of our solutions. The challenge is now going to be to find the second solution. So to do that, we look at the first equation that we were given when we were asked to solve the simultaneous equations, and we're going to substitute the value we've just calculated into that equation. So we know y is 1. So this equation can be written as 3x plus 4 equals 1, because 4 lots of 1 is 4. And now we have to solve that equation. So 3x plus 4 equals 1. Subtracting 4 from both sides, so 3x equals negative 3. Dividing both sides by 3, so it tells me that x is going to be negative 1. And we have our second solution. So the two solutions we've got is x is negative 1 and y is 1. Now what's really nice with simultaneous equations is we can check it. And we use the second equation this time. So the second equation said 5x take away 3y equals negative 8. If we substitute the value of x as negative 1 into the 5x term, so 5 lots of negative 1 is negative 5, and y is 1 into the 3y term, so 3 times 1 is 3, then minus 5 minus 3 equals minus 8. Yes, it does, and we got the right answer, because that's what the equation told us it was going to be. Okay, so here's a full example. 7x minus 3y equals 37, 4x plus 5y equals 1. Okay, again, we can decide for ourselves which equation we want to deal with, whether we want to go with the x's or the y's. So I'm dealing with the x's here. So times in the top equation by 4 gives me 28x minus 12y equals 148. And times in the second equation by 7 gives me 28x plus 35y equals 7. We've got the same number of x's in each one. So I'm going to find the difference between the two equations. Now, on the left-hand side, to go from negative 12y to 35y, that's an increase of 47y. And going in the same order on the right-hand side, from 148 to 7, it's gone down by 141. Now, 47y equals negative 141. We divide by 47, and it tells me that y is going to be negative 3. So negative because it's gone down, obviously. So when working out the difference, as I said previously, we work out the difference on the left side and the difference from on the right side. And we've got to go in the same order. So if we go from the top equation to the bottom equation, that's fine, but we must do it for both sides of the equal sign. So now what we've got to do is we've got to calculate what x is going to be. We know y is -3, so by substituting that value of -3 into the first equation, which was 7x minus 3y equals 37, that becomes 7x plus 9 equals 37. Y plus 9? Well, because -3 times -3 is plus 9. We can now solve that equation, so 7x plus 9 equals 37, subtract 9 from both sides, 7x equals 28, divide both sides by 7, and we get x is equal to 4. Okay, we're going to check this in our second equation. So our second equation was 4x plus 5y equals 1. We know that the value of x was 4, so we can work out what 4 times 4 is. And we know the value of y was -3, so work out 5 times -3. So we've got 16 minus 15, which equals 1, which is what we wanted.